Hello, everyone. Thank you for joining us today for this USEA Consensus webinar, an introduction to the Carbon Ore, Rare Earth, and Critical Minerals, or CORE-CM initiative for U.S. Basins, Part 1. This is the first in a two-part series, the second of which will take place next week on December 8th, beginning at 1 p.m. Eastern. My name is Alex Krauke, and I'm a consultant with the U.S. Energy Association based out here in the Seattle area. For those of you who may not be familiar with it, the USEA's Consensus Program, which I consult on, is a cooperative program with the U.S. Department of Energy's Office of Fossil Energy and Carbon Management that seeks to educate the public, policymakers, industry, and other stakeholders and build a consensus on the benefits of and requirements for CCUS, as well as other carbon management technologies, such as rare earth elements and critical minerals, which we'll be discussing today. We do this through a series of activities, including briefings such as today's, workshops, reports, and monthly news clips. If you would like to subscribe to our mailing list, please feel free to email my colleague Michelle Littlefield at mlittlefield@usea.org. Before we get started, I wanted to share this interesting visual from the Visual Capitalist to help demonstrate the scale with which we're working, particularly in regards to rare earths, which I acknowledge is not the only topic we will discuss today, however, incredibly important. I think the foreign policy implications are pretty clear here, but we are here to discuss more kind of the domestic activities. So as you'll see in the visual, the U.S. currently has about 1.5 million tons of rare earth reserves, and in 2020 had mine production of 38,000 tons, meaning at current rates, our supply of rare earths would take us to about 2060 or so. However, due to their importance to our decarbonization goals, defense applications, and just general importance to life in the 21st century, this production really needs to scale quite rapidly. Which brings us here today, where we'll see how DOE plans to tackle this challenge, in particular through its CORE-CM initiative. Shortly, I'll pass it over to Dr. Grant Bromhall, Acting Director of the Minerals Sustainability Division of DOE's Office of Fossil Energy and Carbon Management, where he'll give a program overview of CORE-CM. He will then be followed by a series of short presentations from Tom Erickson of the Energy and Environmental Research Center at the University of North Dakota, Scott Quillinan of the University of Wyoming School of Energy Resources, Brent Sheets from the University of Alaska Fairbanks' Petroleum Development Lab, and Dr. Michael Karmas from Virginia Tech's Center for Coal and Energy Research. Following their presentations, we'll take a short bit of time for audience Q&A to kind of break things up a little bit. And then we'll be followed by another series of short presentations from Dr. Sarma Pisupati and Dr. Barbara Arnold from Penn State's Center for Critical Minerals, Dr. Charles Sims from the University of Tennessee at Knoxville, and Dr. Samuel Taylor from West Virginia University's Energy Institute. We'll then follow up with a last round of audience Q&A and then adjourn for the day. So quite excited to have this webinar with you all today. And with that, I'm going to pass it over to Grant. Grant, the floor is yours.
All right. Thanks very much, Alex. Can you see my screen okay?
Yes, perfect.
All right. Well, thank you very much, and thanks to everyone else for joining us today. As Alex mentioned, I'm going to share some of what we've been doing within the Department of Energy and a brief overview of the CORE-CM initiative and a lead-in to all of the really excellent presentations that you're going to get a chance to see today that give you the details about what's happening across the CORE-CM initiative. Just sort of following from the stage that Alex set here. Here are a look at some of the critical minerals and the rare earth elements that we're looking at. 32 of 35 of these have been determined import dependent, which means right now we get more than 50% of these from a foreign source, and at least 14 of these were import reliant upon. So there's a substantial challenge. When you pair that with the fact that with our clean energy goals and targets for the future, looking at the potential growth in electric vehicles, electricity networks, hydrogen, wind, and solar by 2040 and by 2050, we're looking at a fourfold and a sixfold increase. And in the Sustainable Development Scenario, this analysis was done by the IEA earlier this year. You can see that we're talking about 42 times more lithium, 25 times more graphite, 21 times more cobalt, 19 times more nickel, 7 times more rare earth. So even above this 4 times average needed, there's going to be substantial increase in all of these that are needed moving forward. And so within the Department of Energy, what are we trying to do to address that? I wanted to just give a very, very brief overview of this. This is not meant to be comprehensive, but we're working to, in general, diversify supply. And that's what you're going to hear a lot about today, especially looking at non-traditional sources, unconventional sources, secondary sources, things like mine tailings, coal measures, coal refuse, produced waters, acid mine drainage, geothermal brines, hard rock mining tailings. All of these kinds of things are the kinds of sources that we're looking for beyond just the typical mining sources that we've generally looked for in the past for these. Obviously, also we're looking at, across the department, looking at developing substitutes. So if there's ways to reduce our dependence on the rarer materials, that's something that we're trying to do. So for example, reducing the use of cobalt in batteries is something that a lot of people are working on. Recycling and reuse, as the pool of materials that we've generated for batteries, for magnets, etc., gets older, there's going to be a bigger and bigger market for the recycling, but it's not an easy thing to do, and so we're looking at opportunities to recycle these, in general, reuse of all of our streams so that we can take advantage of those and gain benefits by really using our waste streams to add value. And I think you'll hear a lot about that in the CORE-CM projects today. Also, making sure that we consider everything from a systems perspective, and especially with the passage of the recent Infrastructure Act, looking to move technologies and techniques down the TRL technology readiness level scale towards demonstration and towards aiding in commercialization. That's going to be very, very important. Of course, we also engage a broad number of stakeholders with the Loan Programs Office and our Technology Transfer Office, for example. Additionally, DOE has a major role in the National Science and Technology Council Subcommittee on Critical Minerals. We have one of the co-leads of that organization from DOE. Here's a broad group of organizations we work with across the federal government in this. Helping to stand up domestic supply chains for critical minerals is something that no one organization and not the federal government itself can do alone. So we're engaging broadly across the federal government. We're working with international standards organizations, and we're hoping to work with, and through the CORE-CM initiative, as you'll hear more, we're working with our university communities, industry, state organizations, et cetera, to build the coalitions that we need to make this goal successful. The division that I run, as Alex mentioned, I run the Mineral Sustainability Division within the Office of Fossil Energy and Carbon Management. Just very briefly, that's where the Core CM program fits under. I wanted to describe what this division is about. We begin with resource characterization, technology, and development, looking to characterize what the opportunities are. That the Core CM is a lot to do with this, but also sustainable resource extraction. So we're looking at how do we get the resources out of those materials, and how do we process, refine, and create alloys and metals from those critical materials. Also, when it comes to carbon ore, looking at what kind of manufactured products can we take that carbon ore and process it and manufacture it towards. So we're looking at all stages of the supply chain for critical materials and for carbon ore. And you'll see that again in the Core CM. Just to give you a sense, some high-level numbers on the critical minerals possibilities. These numbers are work that we've done previously in the program, focused on resources associated with coal. But as I mentioned, we're looking at a lot more broad numbers. But even just looking at the coal numbers, you can see they're quite substantial. In known coal reserves, there's 11 to 17 million tons of rare earth elements. And that current production, that's about 30,000 tons per year. So that's around double the current use of critical materials. But there's a lot more. There's a lot of additional in recovery from refuse piles, ash impoundments, and from acid mine drainage. And here are just some rough estimates of what we can find in different portions of the country, mainly in the Appalachian region here. But we're looking for the Core CM initiatives to help us fill out more details on these in regions across the country. We've also demonstrated very clearly that we can produce high quality products greater than 98% purity from these dilute sources, from coal, from refuse, from ash, and from acid mine drainage, all four. And so that leads us to have confidence that we can build these out further. In order to do that, we've had some pre-feed studies for large-scale pilot projects that are looking to generate 1 to 3 metric tons per day of critical minerals and rare earth elements with advanced separation technologies combined with conventional technologies as well. So very briefly, the opportunity. There are a lot of abandoned mines. This map comes from USGS data. There are, as you can see, there are a whole host of mines across the U.S., and there are significant potential resources associated with the mine tailings here. For just the coal mines alone, there are more than 6 million tons of rare earth elements that are associated with the coal that has been produced from those. So there's a really significant resource. You'll see that as you might have expected, when I showed the Core CM map, these regions here are highly associated with the regions across the country where the Core CM initiative projects are occurring. There are lots of coal-fired power plants which are near ash deposits and acid mine drainage locations, etc. So here's getting down to the details of the Core CM, and I don't have a whole lot more to say on this other than I just want to cover basically what the Core CM program is about, and then you'll hear the really specific details on what each of the different projects are doing in the course of the next 2 hours. But as you can see, there are 13 different projects spread across the U.S. in different regions. We're looking to create broad-based regional coalitions. And these are going to help us investigate the regional resources that are within and around these regions, not just the materials, the minerals that are associated with these different sources we've been talking about, but also what are the facilities, what's the infrastructure in place, what's the workforce resources that are available. A lot of these initiatives are in locations where there are impacts associated with the clean energy transition. And so we want to do what we can to catalyze economic growth and well-paying job creation to make up for any changes in the energy economy related to those. And so again, sort of describing at a high level what the CORSIEM initiative is about. We want to build coalition teams, and this consists of universities, of industry, state, local, tribal, federal government personnel to help design and implement strategies for each of these regional basins to see their highest potential for producing rare earth elements and critical materials. We want to catalyze the economic growth and job creation, as I mentioned before. And we want to take a regional approach, and this is something that DOE is looking at more broadly, looking at each region's unique attributes. It's called a place-based approach, where we're looking at what happens what's going on within each region. That is often as important as some of the technology that's being developed in determining what the future holds for that region. This approach gives us a chance to explore that. And then we want to accelerate the potential for in the upstream and the midstream, in particular of the critical mineral supply chain, standing up of those supply chains, and in the downstream for the manufacturing of carbon-based products. So when CORSIEM was created, the plan was for there to be multiple phases, and so I just wanted to talk about that very briefly. In the first phase, and that's we've just started these earlier this quarter. And so we're obviously at the beginning of phase one, but in phase one, we're looking to identify and characterize the resources for critical minerals and carbon ore within these regions, assess the technology needs, understand the industrial and energy needs within each basin, and develop strategies for how these resources can be used and more fully developed. And then in phase two and three, we're looking to further build out on the foundation that we built in phase two for characterization, for technology development and field validation. Again, building on these strategies, designing technology innovation centers for the regions, and then moving towards implementing the strategic plan for the regions that we come up in phases 1 and 2 into a phase 3, making sure that we have programs for outreach, education, and training as we build that. These become these plans for the future become particularly important and will probably evolve somewhat, especially as the Infrastructure Act that was recently passed has significant areas of funding related to critical minerals, supply chain development. And so what we'll be looking to do is finding opportunities to help feed into programs that are in the infrastructure bill with the strategies that we come up within the CORSIEM initiative. And then I just wanted to end with a couple of cross-cutting themes that we'll see across all of the different Core CM initiative projects. Environmental justice, very important as we consider what's happening in each region and in each locality. Characterization methodologies, remediation opportunities, separations and extraction processes. So how can we, these will be different based on the feedstocks, but there will be some similarities across these in all the regions, and whatever we can share about what we learn in these is going to be important. The technology innovation centers that we stand up, how can we design those in a way that it's most effective towards building out in the communities, and engagement and outreach, of course, is going to be very important for all of these. And so with that, I finish, and I'll turn it back over to you, Alex. And I guess we're taking questions a little bit later time.
Yes, correct, Grant. We will take questions after the first set of presenters. And just want to say thank you so much for that. It's great to see the work that DOE is undertaking with this exciting opportunity, and great to see your leadership of it. I'm now going to pass it off to Tom Erickson to discuss his work up in North Dakota. Once Grant stops sharing his screen, Tom, feel free to share yours. And the floor is yours.
All right. Well, thank you very much, Alex, for the invitation, and as well for the opening comments from Dr. Bromall on the Core CM initiative. So the title of our initiative is the Williston Basin Core CM initiative. In a graph very similar to what Dr. Bromall had shown, we are located up in the upper Midwest region, the large yellow spot here, area of interest number 6. And our focus is really to build on over 70 years of natural resource development that has already occurred in the Williston Basin to provide new resources and materials to serve the United States, which is what North Dakota, Williston Basin has done for many, many years as a significant energy and natural resource exporter.
Tom, sorry to interrupt. Do you
Yes.
mind just putting in presentation mode, please?
Oh, I'm sorry. I thought there we go. Are we there now?
That's perfect. Thank you.
All right. I apologize. So the Williston Basin contains significant lignite resources at current use, and we have significant use of it with large coal-fired facilities for electricity production as well as for synthetic natural gas. Contains significant amount of over 800 years at current uses. We have significant infrastructure for mining, transport, resource processing already within the region. You may be familiar with the recent Bakken oil boom, which really kicked off in about 2011 in our region. Massive growth in many industries in our region that we had to bring forth to keep up and basically go from a small oil producer to be the #2 oil producer in the United States today. So it's demonstrated its ability to do that. And of course, significant research has been done both on just characterizing the resource that we have, as well as developing the technologies for the future. So our approach and deliverables are very similar to the approach and deliverables for many of the programs, but the first one is to assess whether it's analytical information regarding the resources that we have, whether it's the technologies that are able to utilize those resources, looking at the various waste streams from all of the processing that's been done over the 70-year history of the Williston Basin, to assess all of that information, to then identify where the gaps are so we know what additional information we have, and to develop plans to go to that next phase 2, as had been mentioned earlier. And the various deliverables mentioned here are really similar for the majority of our programs. The one thing, Technology Innovation Center. So we are currently evaluating what we need. The Williston Basin, and really led by the state of North Dakota, though we encompass Montana and Wyoming and reach into Alaska, really the state of North Dakota has been the lead in developing the Williston Basin, and they have developed numerous public-private partnerships, whether you want to call them technology innovation centers or whatever you may want to call them. They have developed those to help spur forward the exploitation of the Bakken resources, conventional oil resources in North Dakota, as well as coal resources. And we see that same thing even in ag, which is a big part of the state of North Dakota. So we have a number of things to draw on, and we will be taking a look at what we need to do to continue to accelerate the research, really support that public-private partnership side of it, and to advance the education and training activities to make sure that we are ready and able to bring forward the workforce that's necessary to exploit the opportunity and to serve the United States as a whole. Our team, again, it's led by the Energy Environmental Research Center. We are part of the University of North Dakota. We are a separate entity from the rest of the academic programs. However, so we also do have from the College of Engineering and Mines, the Institute for Energy Studies, who has been very active in this area as well. And on the business side, the Nistler College of Business and Public Administration, all three being part of the University of North Dakota. We're fortunate to have Pacific Northwest National Laboratory, as well as North Dakota State University, our sister university to the south of us about an hour, and as well as Montana Tech and through Ames, the Critical Minerals Institute. That really comprises the primary research team that will be addressing the issues within this opportunity. However, we have many other project partners. First and foremost, the North Dakota Industrial Commission, which really is the state of North Dakota, and their willingness to participate with significant resources and time into this program. We also have from the industry side, North American Coal, BNI Energy, which is also BNI Coal, Minn Kota, which is one of our electricity producers in the region, also one of the leaders in carbon capture, which we hope to see Project Tundra get off the ground here with the full-scale carbon capture system in the upcoming years, and Basin Electric Cooperative, one of the larger cooperatives spanning really from North Dakota all the way down to, I think, just touching the tip of Texas. Other groups such as Current Lighting Solutions, users of rare earth elements, Northrop Grumman and General Atomics, two companies that are very active in North Dakota, also very large users of critical materials and rare earth elements. Their activity in North Dakota revolves largely around unmanned aerial systems. We're very fortunate to have them as partners on this project as well. The geological surveys from North and South Dakota, and then various others. I'll point out Semplastics lower down. Semplastics is an entity that creates building materials from coal. We've been working with them for a number of years. Very happy to have them on board. And then down at the bottom, I also have the 4 of the other schools in the programs that we agreed to look for ways to work together throughout this program, especially in sharing of some of our stakeholder outreach activities as they go forward. The benefits to the Williston Basin, I mean, we already are an energy exporter. That's what we are known as, whether it's electricity, whether it's fuel, as well as ag products. We export outside of the state. We're a relatively good-sized state, but with a population of only 750,000 people. So that is what we have done for years, is to develop industries, to take our resources and then move them out for the benefit of the rest of the United States and for the world, for that matter. So to continue and expand the use of our vast lignite resources is first and foremost the reason, and of course regional economic development to continue to grow the region beyond what it is today. Stakeholder engagement is a big part of it in terms of what as we gather all this information together, putting together the various resources that we have. We'll be leading a number of initiatives and meetings, both virtual and in person, typically associated with other venues and other opportunities, but putting together these resources, working on our website right now to get that up and running, and to engage audiences. I noted a lot of our other project partners or stakeholders previously, but we hope to add many more as we go along, from very specific industry stakeholders to more broad and general stakeholders. And as Dr. Blumhall mentioned as well, the topic of environmental justice, very important, and as well as the whole topic of ESG, as we see in today's society, and very important to the state of North Dakota. We are fortunate we have a governor who has an initiative for the state of North Dakota to be carbon negative by 2030. That is driving many things here throughout the state as to how we pursue things. As you can imagine, we are a fossil energy exporting state, and that's a very big step for us to take and to be able to achieve to be carbon negative over a very short period of time. I was also remiss in noting we do have significant tribal governance and tribal lands in the Williston Basin that we will be working with as well. We have not engaged them as of yet in this program, but we have engaged them in a number of other activities, and of course these are very important to their activities as well. The stakeholder meetings, we're going to be looking at really this virtual one, which is at 6 months out, which is about 4 months out at this point in time. And then an in-person one likely located in Bismarck, North Dakota, most likely where many of our stakeholders reside, many of the industry partners we work with, what we've learned. And then another final one that's closer to the end of the project to go through the results and to really set the stage for the future. So we've had North Dakota has had significant success in building these stakeholder projects, PCOR being our largest one from the past, which is the Plains CO2 reduction program, which was focused on really advancing the topic of carbon capture, carbon sequestration, carbon utilization within North Dakota, in which we're seeing significant activity in the state right now. We hope to build a very similar program to that with this to take this region and advance this opportunity as absolutely fast as we can move it forward. So right now, to date, we've had significant stakeholder participation. We've really had good feedback, good information to build from. We have a great team, I think, to get the job done, to move forward. I think the one challenge that I see at this point is just how do we keep this moving after the first phase? That was mentioned about phase 2 and phase 3 plan, but we know that getting this first phase is really just to set forward the plan and to create this plan for moving forward. We then need to have the momentum to keep it going and to keep it going at an accelerated pace, if at all possible. So that is really the biggest challenge that I see moving forward. But for now, for getting the work done of the initial Core CM initiative, that's moving ahead quite well at this time. So that's all I had at this time. I guess I'll wait for questions at a later point.
Great. Thank you so much, Tom. Really appreciate you sharing your work in the Williston Basin. Next up, we have Scott Cullinan from the University of Wyoming. With that, Scott, the floor is yours. We see your screen and just need it in presentation mode. Perfect.
Good to go, Alex.
Yes, sir.
All right. Well, good afternoon, everybody. It's a distinct pleasure to be here. As you can see, I'm not Aaron Phillips. Aaron had a family emergency yesterday and had to leave. So I'm going to step in and do the best that I can to cover for Aaron. But today we'll be talking about the Powder River Basin Core CM and why we're so excited about it here in Wyoming. Start with our disclaimer, especially important today since Aaron's not here and you're listening to me, that Department of Energy is really not responsible for anything that I say today. But let's start with the vision. So the vision of this program really is to provide economic benefit for the Powder River Basin of Wyoming and Montana. And it isn't just about Wyoming. I want everybody to know that we're working closely with our counterparts in Montana. This is a two-state approach. It's just the more we work together, the more traction we're going to get. So we're really fortunate and proud to be partnered with Montana in this project. The mission, it's leveraging that highly trained workforce that we already have in the Powder River Basin. We've got a lot of experience around existing coal technologies, mining, the energy infrastructure is in place. The public accepts the energy industry that's there and they're quite proud of it. So for us, this is really about dialing into that pride of ownership of energy production that's already present in the Powder River Basin and offering some new opportunities around coal and around some of the byproducts of coal. So where are we? Powder River Basin. More than 40% of the nation's coal is mined right here between Montana and Wyoming. Largest coal mines in the world. It's low sulfur, it's low ash, it's low upstream methane emission, subbituminous coal, and employs a lot of people. The communities depend on these coal mines. And the coal is thick, over 50 feet, sometimes in 100 feet in some of these coal mines. So the resource is tremendous, and there's lots of it left in the ground. Wyoming alone ships to over 20 power plants in 29 states. So we're quite excited about this program as we start looking about byproducts or coal byproducts that are associated with rare earth elements, critical minerals, fly ash in particular, because it is shipping to so many different locations around the US. And as our core CM team is working on it, as other core CM teams are working on it, they're really working on Powder River Basin fly ash. So it's quite exciting to us that it's a national approach. Not to mention, outside of the coal mines, we do have the Bear Lodge complex, which is one of the largest unmined conventional rare earth element deposits in the US, and that's located just right outside the border of the Powder River Basin. But the communities are connected to the communities here that are in question. In addition to coal byproducts and the Bear Lodge complex, we're also looking at industries in bentonite. The oil and gas industry is prevalent here. Oil and gas produced water, and uranium mining. So I think there's lots of opportunity to discover what the rare earth element resources are that are associated with all these different industries. Technology innovation centers. We have several already in the basin. The Wyoming Innovation Center is a coal to products demonstration laboratory in Gillette, Wyoming. And it's focused on, like I said, coal to products, but the first project that's going to be placed there is actually a rare earth element coal ash extraction pilot. So we're pretty excited about that. We've got the School of Energy Resources Center for Carbon Capture and Conversion, which focuses on high volume coal to product opportunities. Ramaco, which is located in Sheridan, Wyoming, is focused on coal to products in the high value space. And the Wyoming Integrated Test Center, although not focused on rare earth elements, it kind of lays the groundwork for successful field demonstration projects in this space. So what are we doing with technology innovation centers? We have so many already operating in the basin. So what we've decided to do is bring in a third party to do an audit of the existing centers. Audits may be a strong word. We're not looking at their tax filings. But what we want to do is just identify the strengths and weaknesses of all of these different technology innovation centers and identify where the research gap lies, where we can strengthen them, where we can grow them, where there's opportunity to invest in new centers. So the key pieces of the project, if you could boil it down into 4 buckets, these are the 4 buckets we would put it in. Resource assessment, both primary resources and waste streams. We want to know where the infrastructure lies, what industries are interested, what industries are out there that can take advantage of this new industry, and really start to develop the foundation behind the commercialization plans for this industry. We're also looking at technologies that can be used in both the exploration mining space, extraction space, processing space, and then probably one of the most key pieces of this program for us is just the outreach and education, connecting those stakeholders and developing vehicles for technology transfer. So what's our primary goals? Really, workforce development is one of the big ones. We're working closely with the community colleges in both Wyoming and Colorado to make sure that the knowledge is transferred down to the community colleges, and so that they can help in training the new workforce for this new industry. Connecting stakeholders across the supply chain. We've done a great job doing that so far, and it's really neat to see that those conversations are already happening, even though the grant just started a couple of months ago. Compiling existing data, identifying where those data gaps are, where we need to invest resources to increase the understanding and for commercial deployment. And really it's about developing those strategic plans so that as we move into phase 2 and phase 3, that those can be deployed and really gain the traction they need to. So who's on our team? It's led by the School of Energy Resources, and we have several different departments across campus that are on our team. The first tier here, if my pointer works, the first tier here, that first square, is kind of the core team. That's the team that are tied to tasks within the SOPO. And then the broader team down below is more of those are the team partners. Those are the ones that are bought in, they're in project communications, they're working with us, they're committed to moving this forward. I just noticed that Aaron made this look like a cowboy hat, which I think is kind of neat. So why the Powder River Basin? It is a traditionally fossil fuel heavy producing region. It's coal, it's oil and gas. Mining is in the DNA of these communities. So it's so important that as we go forward that we find new narratives for coal, that we find ways that these communities continue to do what they have such a pride of ownership in and continue to have jobs and continue their way of life, really. So we're looking for sustainable workforce opportunities, economic diversification, and those environmental and social justice considerations, which in my opinion is really going to help bring a lot of the commercial development back to domestic production. So how are we doing this? We've already been contacting our stakeholders. We've held a kickoff meeting. We've sent out some surveys, and we've asked everybody across the team to say, okay, which theme are you most interested in? And so we've sent out, you can be in more than one, and we've had great feedback so far. So what we're doing is all those different stakeholders that are out there are now being kind of placed in the different areas and different technologies that they're most interested in. And we've also asked them, what level of participation do you want? A lot of them want to be active voices in the room and driving this forward, and others just want to really just kind of sit in the back and listen and learn, and that's okay. So that's what we're doing, is understanding where their level of participation lies and what they're most interested in. So this will be used for the technology transfer workshops that we hope to kick off next winter. And then we'll be reporting on that in the annual forums that will follow in the spring of each year. Resources that are going to be deployed. We're pretty excited about the MAP program. So that's working with our local maker spaces, our community colleges, and it's developing a digital certificate workforce training so that folks can dial in on their own time, go through these digital workforce trainings and get a little certificate that says, okay, now I'm educated in rare earth element X or critical minerals X, or I've worked on some coal to products. So we're pretty excited about rolling that out into these communities. Really just data sharing, knowledge transfer, getting it out, connecting our stakeholders, using the outreach mission here at the school, and really getting that conversation going. Environmental justice was mentioned. That is a subtask in this project, and that will be led by our Center for Energy Regulation and Policy Analysis. So this is a group that's really dialed in both at the state level and at the university level, and can really connect people across this space under that topic. Environmental and social governance, I've already mentioned that mining is really in our DNA here. So we need to make sure that these communities out here aren't left behind and that they have opportunities for new training, new workforce development, and really continue that pride of ownership that we have. And lastly, the standards development. Just like to say thank you to Dr. Carpenter and all his work that he's done with the ISO standards, and that really is going to be an important piece, in my opinion, to the overall domestic development of rare earth elements and critical minerals. As companies continue to dial in those ESG goals and define what they're going to pay for, I really think that having those standards and being able to do it here in the US, here in Wyoming, to a certain standard that companies want to buy the product is going to be so important to bring some of these industries home. So progress to date, we have had the stakeholder kickoff meeting both here in Wyoming and the DOE kickoff. We've sent out our informational survey. Last month, we held a rare earth element critical mineral webinar, so how we can get the wheels turning here in Wyoming. We had over 300 participants dial into that. So we're pretty excited that the level of excitement here in Wyoming for this program and for the industry in general. We've done all the task leaders are ready and moving forward. We're starting the literature reviews, and we're constantly communicating with our stakeholders. So we're off and running. Challenges and opportunities. So Aaron has listed restrictions to travel. The first, that is a tough one. This is such a relationship building based program that being restricted to travel to build those relationships is going to be tough. But I think really the opportunities for this program, and Grant, I'd like to praise you and your colleagues for coming up with this. I really think the Core CM initiative in general is brilliant. As this rolls out, as we start to identify where these strategic plans can be built and how we can get momentum and moving in that direction and moving into phase 2 and phase 3, we can really move the needle on this one. So with that, let me stop talking and I'll give it back to you, Alex.
Great, thank you so much, Scott. Great to see the work in Powder River Basin with Wyoming's cowboy hat worth of partners. So next we have Brent Sheets from the University of Alaska Fairbanks. Brent, you're sharing your screen already, so go ahead and put it in presentation mode and you are good to go.
Yeah, I can get it in presentation mode. I just couldn't figure out how to unmute.
If it's not one thing, it's the other.
Details. There we are. Yeah. Well, I appreciate the opportunity to bring everybody up to speed and introduce you to our project here in Alaska. Our vision is the same as the title of our project, which is just bringing Alaska's core CM potential into perspective. Now, Alaska is big, so we have to have a mission that is even bigger than the state of Alaska. And that's to establish a core CM industry in Alaska. And we're going to do that by working with the industry and the other stakeholders to identify the opportunities that are here and to establish our plans and development scenarios for phase 2 for our TIC and actually maybe implementing some of the plans that we come up with. What is our region? Well, our region is big. It's Alaska. So unlike the other places, we don't have a specific basin. I would like to point out how big our state is, hence the area there that you can see our state overlaid with the lower 48. That's how big our region is. Where will our TIC be located in this massive region? Our TIC is going to be jointly located at the University of Alaska Fairbanks, which is right in the middle of the state and a lot of mining activity around here, and the University of Alaska Anchorage, which is where a lot of the industry is headquartered. Stakeholder groups are there, all the native organizations are there, government has plans there. I think by having this TIC jointly operated in both of the cities, which are arguably the 2 largest cities in Alaska, we pretty much have access to all of our critical stakeholders. Now, Alaska is a mineral frontier for the US because we have many mineral-rich regions and a lot of favorable geology, and the likelihood of new discoveries is higher in Alaska than probably any other parts of the country. I don't know if you can see my cursor, but I'll move it around a little bit. We have several mineral belts with a number of critical minerals identified, a lot of high potential on the North Slope, the Seward Peninsula, which already has some activity from Graphite 1, interior Alaska with some leases from CBMR, and then the southeast area, which is of interest to UCOR in particular. But I named those 3 companies and I'll get more into detail about why later on. But because we are still very much a frontier, we're going to use existing data and existing core and maybe collect new field data to create a database of the most promising areas and create a priority matrix that has to do with identifying the opportunities. And we're going to engage our native corporations. The State Geological Survey is our co-PI on this, co-manager. They have a geological materials center, which I'll talk a little bit about, in Anchorage, which is a tremendous asset. And we have commitments from most of the native corporations, which also own the mineral rights to the largest private sector landholder in Alaska. And they have the mineral rights to their lands and a lot of proprietary data that they've already committed to sharing with us. So, as I said, unlike the continental US, characterization of carbon ores is in its infancy here. So we are going to be calling information from existing published and unpublished data, new data from archived legacy samples, and new data from newly acquired field samples. All of that is going to get posted to the DGGS, that's the State Geological Survey, website. They do a phenomenal job of putting reports out there, and it's a tremendous asset for us. That's one of the key things that we hope to do in terms of identifying the opportunities. I mentioned the DGGS's Geological Materials Center. It's like that last scene from Raiders of the Lost Ark. It's a former Sam's Club with just aisle after aisle of racks, and each of those racks has core, cuttings, minerals, surface collections, a variety of things. So in the course of coming up with our basinal assessment, our geologists are going to be identifying promising areas, especially those that are co-located with carbon, because that's been overlooked, and identify where we think we can maybe find those rare earth elements. And then we have our library full of materials right there in Anchorage, where we can most likely find samples that we can begin some like handheld XRF type things. And we are working with some technology providers, by the way, to fine tune some of those handheld devices. And when we find promising areas, then we can take it on to the ICP type analysis, and all that will inform our databases. Another key element that we have is public sector involvement. I'm going to highlight these three companies because they all have leases in Alaska, and they all have significant business plans for investing in Alaska. And they have individually reached out to us and asked to be participating with us in establishing our Technology Innovation Center. So because there is a significant private sector investment, our team is committed to coming alongside this industry and help them realize their investment. So UCOR, for example, is working toward having an operating separation plant near Ketchikan, Alaska by 2024. They're already participating in our weekly project calls and helping us set up our TIC. Graphite One is North America's largest large flake graphite deposit that they have on the Alaska Seward Peninsula. That's near Nome. And there's a minimum total resource there of about 11 million tons of graphite. And it's large flake, like I said. And there's also, we know that there's small amounts of rare earth elements identified with them. So we're looking forward to working more closely with them to realize the potential of their graphite find. And then CVMR is the latest ones to have contacted us. They do have a number of leases in the state of Alaska. We've had a couple of meetings. They are already joining in our weekly project calls, and similarly have expressed desire to invest in our Technology Investment Center. So we're pretty excited that we have such deep roots here in Alaska and such momentum already going into this. One of the other key elements that we'll be doing is we're heavily reliant on stakeholder and public input. So we're going to start, and I'll get into more details in the next couple slides, but we're going to be seeking an industry steering committee for most all of our tasks. We'll be having several public meetings and giving them opportunities to comment on our plans. That's going to create a priority matrix. From the priority matrix, we will come up with some development scenarios that we hope to pursue during phase 2. We'll again be going back to the public and seeking expert judgment and environmentalist input and other stakeholder groups to tell us if our development scenarios are good. And then the outcome of that is going to be hopefully a development scenario that everybody buys into. Obviously, the nation needs to increase its rare earth elements and critical minerals production, but the extreme environment sensitivity that there is around the tundra and the permafrost covered areas in Alaska, the sensitivity of Alaska's fisheries to any sort of threat of damage to their ecosystems, and of course, the importance of subsistence hunting and fishing to Alaska. It makes it imperative that development of the rare earth elements and critical mineral resources, including the value-added processing that might go on with them, be environmentally responsible. So we're starting with that framework. Here's a list of our team members. I've already mentioned UCOR, CBMR, and Graphite One. The rest of these each are assigned a task and is helping us to implement our overall plans. But our stakeholders are just as vitally important. I've already mentioned Native corporations. If there's time at the end, I'll tell you a little bit more about the history of them and why they are important. But they have many of the mineral resources in Alaska, and they are responsible for developing those mineral resources for the benefits of their tribal members. So we also plan to do a little bit more outreach to our hard rock mining operations. When we initially wrote our proposal, we were focused on carbon ore basins, but it's becoming more and more apparent that we've got a little bit more freedom to engage with the hard rock mining industry as well as like the coal and graphite industry. So we'll be reaching out to some of the larger mines in the state as well about tapping into their resources. Why is this project, the CORE-CM project, important to Alaska? Well, my background is coal and oil, and I often joke with our team that if you give me a rock that doesn't burn, I really don't know what to do with it. So at our weekly meetings, I'm constantly exposing my ignorance to it. So I'm going to focus on the coal. You know, in Alaska, we have more than half of the nation's coal reserves, but we just have one very small operating coal mine in the middle of the state. That represents a tremendous opportunity to be developing these other coal finds throughout Alaska and generating a higher value product, non-fuel products, which is a part of the emphasis of the core program. And we have partnered with other universities like University of North Dakota and Utah and others to figure out how best to add value to some of those carbon products. And we're also engaged with a number of private sector companies already to look into some of those things. 95% of the coal in Alaska is found in the Cook Inlet region, Central Alaska, and the North Slope provinces. Now, most of the population is in Central Alaska, Southeast Alaska, and the Cook Inlet region. So there is a built-in market right there. Why else is this project important to Alaska? Well, have I mentioned Alaska's pretty big? There are tantalizing hints of rare earth elements and critical minerals throughout the whole state, many of which are near some operating hard rock mines. So the objective of this project is to better understand the potential for developing those resources by bringing them into perspective. So how are we going to do all of this? Well, I'm not gone into the tasks, of course, because we don't have time for that. But each of the tasks are feeding into a matrix that we're developing so that we can identify the opportunities and score them. Once we kind of flesh that out a little bit, we're going to present that to the public in a stakeholder meeting, which is scheduled for January 18th down in Anchorage. It'll take us a while to work through this priority matrix and to come up with the various rankings. But when that's done, we're going to take the one or two highest ranking opportunities from that priority matrix and start putting those into development scenarios. And those development scenarios are going to be the focus of our phase 2 continuation application. And again, these development scenarios will be informed by stakeholder input, by experts that we seek out. And then also going along with that development scenarios, we are going to be able to identify the research needs. And those research needs are going to feed into our plans for implementing the Technology Innovation Center again in phase 2. So that's kind of our plan for how we're going to engage the public. And again, a big part of this is going to be the Native corporations because they own many of the mineral resources. In 1971, the US Congress passed the Alaska Native Claims Settlement Act, or ANSCA, and it divided Alaska into 12 regions. So Alaska Natives then organize these regional corporations for each region. Each region also has various village corporations, which has surface rights around their lands. So any development scenario is necessarily going to have to involve that community, and especially with respect to the subsistence needs. This is just a little sample of how our priority matrix might look. We have a little farther along than this, but this is the one that I'm going to put out here for the public at this point. You know, we'll be looking at environmental justice issues, technology. Many of the areas in Alaska are remote. How are we going to get there? What's the logistical supply chain? We might have an area of really high concentration rare earth elements, but it's environmentally unacceptable to disturb that area. So we might end up on our priority matrix finding a lower concentration opportunity, but much closer to roads or waterways and much more accessible. So that's kind of how our approach is looking. And with that, I will turn it back over to our mediator.
Thank you, Brent. Thank you for presenting the map with Alaska overlaid on the US. As I don't think most of us remember quite how big the state is and the vast area of your scope. Next up, we have Dr. Michael Karmas from Virginia Tech. Michael, go ahead and share your screen, and the floor is yours.
Okay, can you see it okay?
Yes.
All right. It's a pleasure to be here in this webinar and say a few words about the Evolve Central Appalachia Partnership. This is our project, and you can see here also my personal information. If anybody wants some more information, questions, or anything after the meeting, you can get in touch with me. So basically, and we can go to the next one. Let's start with some acknowledgements. I want to thank the Division of Mineral Sustainability for all the leadership that they have. Secondly, we have an awful lot of partners, research partners. I want to thank them all for their help. And in addition to that, we do have including a group of what we call supporting companies and organizations who have been quite incredible in providing support. And you will see all this in a minute as I go along. So we are the Central Appalachian Region Partnership. At that, I need to provide a definition of what that region is. It means it has been defined in two ways. One, using administrative units per the Appalachian Regional Commission. Basically, this is done in counties. And secondly, also using the USGS core region definitions, and when all these systems combined together, then these are the counties that we're using for our own area and fence. So we do have significant number of counties in East Kentucky, East Tennessee, Southwest Virginia, and the southern and western portion of West Virginia. We are a truly public-private coalition, as you will see in a minute. Our group, it includes academic institutions, mining and energy industries, government agencies at both at the state and federal level, research laboratories, expert consultants, and technology companies. For example, just to see our research team, these are the people who will have contracts, deliverables, and they do part of the scope of the work. Includes 3 universities, the mining engineering departments and the Virginia Coal and Energy Center from Virginia Tech, as well as the mining engineering department from West Virginia University and the mining department from the University of Kentucky. You will see there yellow a number of companies, some of which have worked on this space for a long time in other projects. We have great expertise in geologic modeling and in reserve estimation and resource estimation, including all the standards that are used currently for reporting resources and reserves. We do have technology companies, and we do have 2 federal representatives, the Oak Ridge National Laboratory and the U.S. Geological Survey, as well as the Virginia Department of Energy. And I would like to highlight also the Southern States Energy Board, who has been a partner with me on numerous projects, particularly carbon sequestration projects, and also the fact that we have created a coalition between community colleges in our states, which is coordinated by Mountain Empire Community College, and that is a facility which is right in the center of the Appalachian coalfield. And altogether, we have about 18 different research partners. In addition to that, we have what we call supporting partners. These are companies who are not contractually obligated to us, but they are there to provide expertise, assistance, guidance, facility access, which as you all know is very, very important, and open information exchange. All these groups provided letters of support in our proposal, and they are in constant communication with us. They include land and mineral owners, coal producers, gas producers, power companies, economic development regional groups, technology companies who are already providing carbon products, associations, including the U.S. Energy Association, the West Virginia Metallurgical Coal Producers Association, and I also want to highlight our international partners, which are the University of New South Wales in Australia and the CSIRO, which is the largest mining-related sort of government R&D facility that we have. I would like to provide 2 comments on that. If you look at all the coal producers there, they're responsible for 86% of all coal production in Central App. And if you take the land and mineral owners together with the coal producers, well, they control all the impoundments, all the coal properties, all the coal infrastructure, which is quite significant. In terms of power producers, we have a partnership with Dominion, the Tennessee Valley Authority, and I'm pleased to say as of last week, also with AB. So we're covering every power station which is in our region with opportunities to look at fly ash. And I would like to finish by noting we are in discussions with a national NGO as well as a regional NGO to join our partnership to get some additional input from that community. So our principles and goals and priorities is obviously to reduce dependence on the core CM minerals, but also at the same time to establish a stakeholder community who can move forward and produce the kind of infrastructure that we need and the kind of, let's say, partnership that we need to get into commercial deployment in Appalachia. The second is also an extremely important aspect and principle for us. We'll look to develop or adopt technologies, processes, and best practices, aiming for zero impacts. We are looking for respect on equity. We are big proponents on environmental justice and social acceptance. And we like to use the term that it is more common in the mining and the extraction industries, particularly those of you who are familiar with the ICMM and other such entities would like to refer to responsible sourcing, which is basically what you report on an ESG reporting. We also look forward to help and support and complement the Department of Energy and the Critical Minerals Program, and we appreciate all their help. I'll put this there to emphasize even further why we're pushing for very, very green technologies, and that is 2/3 of the average company's ESG currently, that footprint lies with suppliers. And if you look, of course, the car companies are the ones who have come up before everybody else. Elon Musk there on the left, talking about cobalt and how he wants to get rid of it, particularly the conflict cobalt. And then, of course, Mercedes also has a recent announcement about battery metals and what they expect to do. So with all that, the stress and the pressure to develop responsible mining and processing processes is quite significant, substantial, and we need to understand that everything we do or create has to adhere to these rules. In addition to that, from the point of view of developing an industry, which means financing, 1/3 of all US managed assets, we have about $18 trillion on US assets. 1/3 of that is ESG managed. And if you look at the global assets, similarly, 1/3 out of the 140 trillion is also ESG managed. So if you are not in the forefront of environmental and ESG activities, you are not getting access to a significant amount of available money from investors. So if you can set up an industry without investor support, you're not going to go very far. So what I want to say here is not so much to go to all these tick boxes. I've already mentioned this once and another time, but I want to get back to the principles of zero impact. We're following all the sustainable development principles and guidelines from the International Council on Mining and Metals. We believe on recover and restore on waste streams, in other words, 10 liabilities to assets, and on responsible sourcing and ESG. And I have personally challenged all the folks who work in our team to look at 3 major issues to express their commitment to those principles. A, we want technologies and processes that reduce carbon footprint. Secondly, we use minimal amount of water. And third, and more importantly, zero waste products. All that has to be within the social framework to ensure that we get a positive environmental and social outcomes. With that, I want to move a little bit in a minute. I wanted to leave that quote there from out of the United Nations, that we do appreciate the opportunity to sort of subscribe to this particular statement. And in moving forward, if you look at Central Appalachia and you say, well, why Central App? Of course, has been, you know, the hub of coal mining since the beginning of that industry emerged in the US. Since the 60s, and in fact, you can go even in the 50s. There is significant work funded by DOE on Appalachia with focus on Central Appalachia. That you can see data galore out of that particular work that has been going on. We have private data that we can accompany the other data that are out there. So there are significant indications, positive indications that these minerals can be extracted and processed in Central Lab. But at the same time, if you look on the other side, I copied a diagram out of a recent report that was commissioned by, or at least through an executive order by the White House, that recognized Central Lab as one of the highest priority coal and energy communities in need for federal investment for job creation. So we have 2 significant things coming together here. One, we have the coal industry and the power industry and all that infrastructure. We have all the raw material, and at the same time, we're in desperate need to increase the industrial base and move forward. I want to go back to some comments from previous speakers about phase 1, phase 2, and phase 3. That was the original plan for this project, and I think Grant addressed this in his opening remarks. But currently, this is not a phase 1 project, but it is a standalone project. But the scope of it was developed when it was supposed to be a phase 1. So these are the tasks, and essentially, if I go to the red line kind of items, reporting and deliverables are in the task 1, and there will be all the good work on environmental justice and social justice, as well as the final reporting that will be done. But task 2 and 3 deals with preliminary resource estimates. And we have a very aggressive plan to do significant amount of sampling, both on geologic sampling, on various formations of interest, but also on waste streams. And at some point, the whole idea was that on phase 2, you will be doing more or less most of the testing. Not having a phase 2 being a standalone, I would say that the only issue that I see with the project as a whole, as they are, and hopefully we can have a discussion with DOE on that we have significant sampling campaigns, but very limited testing campaigns. And those 2 things are out of whack, and basically they're not helping to do a proper preliminary resource estimations. Key is the infrastructure and gaps. I said this is very important. Technology assessment and field testing. We're looking at innovative technologies in mining, processing, and utilization. My area is not in processing, as many of you will recall. My area is in mining, and extraction. So we're looking at precision mining technologies. We're looking at converting horizontal drilling to horizontal mining concepts. We're looking at micro tunneling, and the same on extraction. We're looking at modular facilities, advanced facilities, and looking drones for collecting samples from impoundments, and many things that we can discuss in another opportunity when we get into the technology issues. So we're looking at innovative technologies. Now, on the technology innovation centers, I work at the university that has about 3,000 centers. I run one of them for the Commonwealth of Virginia. My colleagues at WVU in Kentucky also, they have a lot of centers out there. We have Oak Ridge National Lab, that's another sort of lab facility and center. So I thought, what would be the best and most unique thing to do? And based on my experience with a number of projects out of the carbon capture and sequestration arena, I thought the best thing to do here is to try to develop a demo scale facility adjacent to a resource location which can host, test, and prove at scale various technologies, because I'm cognizant to the fact that not only my partnership, all partnerships are developed technologies, and we may end up with also international technologies out there. And without having a particular demo scale facility to do this, you're getting into this, let's say, valley of no return in a way in the technology arena where you cannot get back out of it. The second assignment for these technology innovation centers is to marry technology with commercial and with acceleration of commercialization, and trying to develop incentives and barriers where also makes sense in terms of technology and production, but also would attract investors. We have been involved in numerous projects before on stakeholder outreach and education. So we have a model and a plan of how to do this. We have members on our team who are parts of ISO, and they have done this based on ISO standards. We have worked with DOE in previous projects on best practices for this, so we're in good shape. The supporting partners that I mentioned earlier, they will provide the core of our stakeholder advisory committee. And we do have that entire, let's say, community college system in Central Lab with representatives in every state to be able to develop curriculum and also deliver curriculum. As we look at this and we look at all the options that we have and the good things, we also need to look at what barriers and issues we might have. Barrier being something that it is very difficult to overcome, issues, something that you can get away with it and get solutions. And the first couple of ticks are really barriers. If your technology is not meeting responsible sourcing, well, that's it, it's done. But we have other issues that we still need to talk about, and in the technology conversation, we tend to ignore some of them. For example, mineral titles. That is not always clear who owns particularly the waste streams resources. Assess reclaimed waste sites and sampling sites from, let's say, owners of go piles who are not interested to be investors, but they're not going to give the go pile for free either. So what liability you collect on a sort of rare earth opportunity because of that. Waste stream regulations and permitting. So I don't think the jurisdiction is clearly defined, meaning are we processing coal or are we processing mineral? Are we talking about impoundments or are we talking about tailings? These are things that they are not barriers, they are issues that need to be faced up front. Another issue is, are we looking at the core cement industry to develop a primary product, the rare earths, the critical minerals, or a byproduct of another operation, let's say coal, or let's say a power plant that creates energy. So how do we see this? And what are the pluses and the minuses? What happens if we're basing an activity on the fact that the mining is producing this waste, we can pick it up, and the mining closes and they have no any more need for that particular waste pond or go pile or whatever it is, that waste stream, and they want to sell it and get away from it and get done with it. There is liabilities with this. Who is collecting this? We need to be openly discussing these issues because there are solutions to this, and we should face them at the same time as we're looking at technical issues. Also, everybody talks a lot about production costs and margins. We all appreciate that other forces are controlling international markets. Prices are more or less subject to dumping, are subject to arbitrage, and trying to meet global prices, it may not be a very easy task at all, particularly with the technology that we're trying to use with very high environmental and social standards. So that means incentives have to be created. There are always incentives for various aspects of industry. As you know, the renewable industry is a good example. There is tax credits for CO2 storage, you know, and we do have some sort of history and experience on this, but I think we need to develop new ideas of what incentives make more sense, including how we can make sure that the community that takes on these responsibilities has a robust community benefit to look forward to going into the future. So the current status for us is, of course, the project started October 1. We're still waiting to execute contract. So the check is in the mail, but it's gonna, you know, we trust the sender. Third bullet is to tell you that we have set up a specific sampling, storage, and classification laboratory in Abington, Virginia, very close to the coalfields. And we appreciate thank the local community who invited us to do that, and is going to be partners there. And so far, we have organized or participated in a number of kickoff meetings. You can see I have ticked them all except the one before last, which I will tick it after the meeting today. I am in discussion with supporting partners, and I'm also in discussion and visiting what we do here in projects like this. We start with elected officials, board of supervisors, and regional industrial development authorities, and we have already started a round. We will do personal visits one-to-one. We can travel, they're not very far away from me, and I can do all that. And then we're planning also a public event at some point into the future. So I thought I gave you a very brief sort of overview of what we're doing and the way we're proceeding, the high level of responsibility we are attaching to this industry, if it's going to be survived, and if people are willing to invest in it. And finally, to mention again, my only concern is the gap between sampling and testing, which wasn't there when that was one of the phases, but it is now when that is a standalone project. With that, I think I'm the last person before questions, so I will stop at this point. Thank you very much.
Thank you, Michael, and thank you for including USCA as a supporting partner. We're definitely excited to continue this great partnership. In the interest of time, we are going to hold off on the Q&A until the end. So with that, I'm going to pass it over to Dr. Sarma Pisupati and Dr. Barbara Arnold from Penn State University.
Thank you, Alex. Let's see. Barb is with me, and she is going to share her screen here. And or let me do this here. Okay. Okay, where share screen? No, it did not. I'm not seeing your yet.
Now we
okay,
see it.
yep, now we see that.
Oh,
Okay,
there you go.
all right, thank you, Barb. Hello, folks. It is our pleasure to share our project and details with you all today, this afternoon. We are running a little bit late. We'll try to keep it as brief as possible, but yet convey the main message. Our consortium to assess Northern Appalachian resource yield, basically as we call it, Canary, of core CM for advanced materials being both, critical minerals as well as part of it is carbon products actually. And I am Sharma Pishupati, and with me is Barbara, and she will be running the show actually and keeping me straight. And the way we have organized the Canary, next slide, please, is our basic mission is to promote, to basically develop plans and promote regional growth and job creation. Obviously, one of the issues that is faced by Northern Appalachian region, particularly large area of Pennsylvania, is coal mining and coal-related things. So domestic production of rare earth elements and also utilization of resources that we have, carbon ores, to make very advanced and very advanced products that we're talking about in this technology-driven society. So that is our mission. And our goal is to evaluate and assess first what we have and what are the things that are low-hanging fruits here that we can easily get to, and then develop a plan actually in this Northern Appalachian region, which is we are covering Maryland, Ohio, Pennsylvania, and West Virginia. And we are not planning to cover here in New York as though the map shows that. I just wanted to make it clear. And who are our partners? Our partners are actually, there are 3 university partners: University of Kentucky, Conacher, and Virginia Tech, Rohan Yoon, and Colorado School of Mines. Eric Spiller will be the lead people there in those universities to help us out in this effort. And we also have several industrial partners. One is Tetra Tech. Tetra Tech has done a lot of work in this area, collecting data and documenting, and Farley Wood will be representing Tetra Tech in this effort there. American Resource Corporation, Materia USA, Texas Mineral Resources. Texas Mineral Resources basically is the Round Top project. Actually, Texas Minerals is part of USA Rare Earths, who are producing these things in Texas. Actually, they have agreed, they have been partners for past 5-6 years in our efforts in this area. So those are our partners. And the way we are going to organize or put together is we are going to have several tasks, as you all know, 6-7 tasks. And each task, there will be technical people who will be together, coming together and trying to assess both the resources as well as the technology that is available. And you can see PSU, there are several faculty members who are involved in this in different areas of expertise, and university partners. Tetra Tech will be involved in this technical part of it. And we also have a project advisory committee, which will be looking at the feasibility. I mean, we can come up with anything that we want, but whether it is feasible, whether it can be taken to commercial level, or how is it, how will it pan out in terms of economics? We have people who are doing this all the time, helping us out. The overall project will be directed by Penn State, and our basic program goals, which cover basically all the objectives that we wanted to achieve, are assess and catalog complete North American basin for waste streams. As you all know, Pennsylvania leads actually in terms of acid mine drainage problem. 5,500 miles of streams are acidified, and we have a serious problem in this region, in Northern Appalachian region. And also we have a lot of, due to past coal mining and other things, refuse piles and mine tail, basically tail dumps and so on, tailing dumps and so on and so forth. So develop strategies to recover from these secondary resources primarily, and how much can we, and what is the cutoff point? That's what we will be looking at. And also assess the infrastructure. What do we have? What we don't have? And which are the industries that can do this? Where do we have to ship these things? And those kinds of business aspects and industrial evaluation we will be doing. And particularly with respect to both technology gaps and business, aspects also, what would it happen? What would happen if we have to ship these things, or we have to involve other people there. And as you all know, Pennsylvania is the carbon product hub. St. Mary's actually has more than half a dozen carbon companies which produce state-of-the-art carbon products. And so we are working with them, actually, we have been. So in the area of carbon products, rare earth elements, and critical mineral production, we will be assessing the region and formulate plans for phase 2, or basically putting up or taking it to commercialization, and develop technology innovation centers. As you all know, we will be facing teething troubles, or that's what happened in 80s and 90s. Penn State played a very important role in developing independent power producers when fluidized bed combustion boilers came into existence. They all came for technical help. So these technology innovation center that we are planning on here in this region is to reach out to these clientele, so to speak, and who will be producing, utilizing all these resources. So I'll expand a little bit more on this Technology Innovation Center in a minute. But as I said, our resource characterization plan includes both the existing data, taking a look at all the data that we have. We are lucky to have in-house a lot of information. Actually, coal data bank, National Coal Data Bank is at Penn State. And we have also, we now house Argonne Premium Coal Bank also here at Penn State. And also we have a lot of, as I said, we work with several utilities, in developing independent power producers, utilizing this coal waste and coal dumps and so on. So we will be working with all those people and using the data that is available, and on top of it, analyzing what is needed and expand the database to the entire basin. As you can see in the graph, actually, we can see a lot of industries that are related to this area are already in Pennsylvania. And we have started the work for DOE in estimating resources of cobalt and manganese. As you can see, we released a report last year, availability and estimate of these resources by looking at what is out there. So we'll continue and expand that database to the entire basin for CORE-CM region, the entire region actually for CORE-CM. And who are our stakeholders who will be helping us? Actually, we already have developed an extensive stakeholders group since 2017 in this area, power and mineral stakeholders group, industrial stakeholders group, which consists basically of about 40 industries, ranging from mining to equipment design, engineering, supplies, environmental, as well as actually people who are using these rare earth elements, producing battery materials and so on, and also landowners, and we have been working with DEP in characterizing and also looking at acid mine drainage and other resources for rare earth elements for quite a few years actually. And in addition to our own stakeholders group, we do work with Pennsylvania Economic Development and Workforce Specialists. There are a few of them that have already promised to work with us, and we are working with them to include everyone in the state who are affected by this. And Coana Industrial Development Corporation and all the, as I said, half a dozen carbon manufacturers in central Pennsylvania or there in here. And so our goal is actually to work with these advanced Margan materials folks have established with Penn State a Center for Excellence in Carbon Science here to develop the state-of-the-art carbon products. So we will be working with all these folks and organizing biannual workshops, outreach workshops to figure out what they need and to transfer the information, to disseminate the information, and to work with all the stakeholders and reach out through educational activities to even people who are related but not directly involved. So that is our plan. And our vision for Innovation Center is somewhat similar to our materials science MRI kind of model. The way it works is it is a public-private partnership kind of thing built around Penn State, and we have built facilities that can take from TRL 1, 2 all the way to 5 and 6 and work with stakeholders group to even look at the economics part of it. These technology innovation centers will test the technologies that are being developed, not only within these universities and partners, but even elsewhere. They will have access to these kinds of facilities and to develop as well as validate whatever they have, the technologies here, utilize the resources that we can provide. We have excellent geological and mineralogical characterization facilities here. So we want to expand that and try to offer them as a part of this Technology Innovation Center to all the folks in the region who can utilize, they don't have to duplicate these, identify new carbon products and critical minerals. So that is our basically game plan. And how is it going to benefit, and why is it important to Northern Appalachian region? I already mentioned that most of this region is affected by traditional coal mining and decline in coal production. So our goal here is to catalyze regional growth back again, and create jobs, new jobs that are more environmentally friendly, and retrain some of the workforce to take up these challenges. And in this process, we are remining and reclaiming abandoned landmines here in Pennsylvania and all the Northern Appalachian region, and remediate acid mine drainage, which is again an environmental eyesore, and also an important issue that is facing our water resources. And reclaim mineral processing and metallurgical dump waste, as I have shown in the map of Pennsylvania. There were several industries that have mined and produced minerals here, metallurgical waste that have been dumped. So we can process those waste dumps and produce the valuable materials that we are looking for, and address both near-term and long-term challenges, again, related to coal mining regions, and develop some research opportunities, needs to make these new products. And as I mentioned again, I'll re-emphasize the carbon materials that we can produce are humongous from the Pennsylvania resources here. Carbon ores, carbon fibers, foams, furnace electrodes, you name it. We can produce all, we can do research with the Carbon Excellence Research Center here that was established by Morgan folks. And that will result in quite a few coal mining related jobs, employment in this region, and address basically the environmental justice concerns. So what we are doing is right now we are organizing our own partners, and unfortunately, with all bureaucracy things, the contract signing got a little bit delayed, But we are simultaneously forming the technical operations committees, as I talked about, for each task, who will do what and how we're going to do and compile all the data. And Barb is going to be in charge of all these operations and doing. After this presentation, she will be taking charge of all these operations. So we have a clear division of how to organize our data and pass it on to NETL DOE for basically archival of the data and samples. And we will have, as I said, the project advisory committee also has been formed. We talked to several of the members here, and we are trying to formally convene the meeting to discuss the course of action and their roles at this point in time. And that's basically what we wanted to share with you. And all the things that we talked about will take us to where we wanted to go. And I thank you for your patience and cooperation. Thanks a lot.
Great. Thank you
Back
so
to you,
much,
Alex.
Sarma, and thank you, Barb. Next up, we have Dr. Charles Sims from the University of Tennessee at Knoxville.
Great, thank you. Thank you for everybody for having me here today. Bring this up and switch this over. There we go. So thanks everybody. Glad to be here this afternoon. I'm going to talk a little bit about the CORSIUM project coming out of Southern Appalachia today. This is a joint project. I'm the PI for this one at the University of Tennessee, and then the recipient of the project is the Composites Institute at IACME, who is a project partner with the University of Tennessee as well. So the project mission for this is really focused on our basin. So you see here a map on the left. This is the Southern Appalachian Basin. It effectively cuts the state of Tennessee in half. There's a Southern Tennessee coal field, but most of the Southern Appalachian Basin is in Alabama, with most of the production that's still going on in the Black Warrior field around Birmingham. There's been coal mining historically throughout this region, but most of the remaining production is still down in the Black Warrior field. And so one of the main missions of our project is to help revitalize some of the distressed Southern Appalachian coal communities that have been relying on coal historically, that are still struggling to try to transition to other engines of economic development. And then the second mission is to really reduce a reliance on foreign imports of REE, rare earth elements, and critical minerals. The region is also becoming a hub for automotive manufacturing and electric vehicle production. And so we are going to, our new engine of economic growth is going to be relying on reliable sources of these inputs. And so the objective for the proposal is to develop and deploy these new technologies for manufacturing REE, critical minerals, and non-fuel carbon-based products from coal and/or coal waste in the Southern Appalachian Basin. So the locations are going to really reflect what we consider our unique resource base. What we have identified as probably the primary resource base are going to be the coal ash ponds. So our region is, depending on how you look at it, rich or poor in coal ash ponds. So Alabama, Georgia, and Tennessee contains almost 250 tons of stored coal ash. That's roughly 10% of the US inventory. And this is mainly at sites owned by two major utilities in the region, Southern Company and TVA, who are both partners with us on this project. And these coal ash ponds typically contain REE concentrations that are about 5 times the average that you would get with the coal here in Southern Appalachia. There's a number of other potential sources, coal surface and underground mines, the coal refuse piles, acid mine drainage waste, co-produced water from coal bed methane wells, coal dewatering plants, coal prep plant waste, and coal mine tailings are all other sources for REEs in the region. And the map here shows where most of that remaining production or where those facilities are located there in the middle of Alabama and a bit in northeast Alabama. We have a lot of the same features as many of the other programs, but we have kind of three that we think are special. So one of them is kind of what we consider, what we've been calling a REE innovation ecosystem. So we have a lot of coal ash in the region, as I pointed out. And this coal ash has high concentrations of REE that are then going to feed in directly to production of batteries, which will then lead into production of electric vehicles. So we have a potential supply chain that is entirely encompassed within the region, which we think is something that's very unique. The coal itself that's in the region is also a major source for carbon fibers, graphite, and graphene. And these things are also critically important for producing these same finished products. We know for electric vehicle production, you got to have batteries, but you also need to keep the vehicle lightweight. So things like carbon fibers and graphite become really important. We also have unique manufacturing R&D capabilities, specifically with respect to carbon fibers, 3D printing, batteries, and graphite. So we've got partnerships with Oak Ridge National Lab, where there's some innovative research going on with 3D printed batteries that we're going to leverage. And then there's also the expertise at IACME around carbon fibers that we'll be leveraging as well. The third piece we find that's very novel and key aspect of this are our novel separations expertise. So obviously to get the RE into a finished product, there's a separation piece that needs to go into this to separate it from the mined material. We have high performance computing expertise here that will be used to help kind of guide these RE separation techniques. And we've actually had one of the core members of the team has kind of produced a recent textbook on this. We also have biological processing as an electromagnetic processing, both at Oak Ridge and UT around separations, and then thermochemical separations and recycling with our partners at InCycle and American Renewable Metals. Our Technology Innovation Center is planning to follow a model that IACME has used in the past to great success, kind of a distributed innovation network affiliate model. So for the composites piece, we're going to be leveraging about 200,000 square feet of facilities in 6 states that are all centered around composite materials and carbon fibers. For the core CM pieces of this, we've identified several facilities at ORNL, Southern Company, the University of Alabama at Birmingham, and here in UT Knoxville that will be focusing on that key core piece of the core CM. And then I've highlighted three key affiliates of this innovation center: the Carbon Fiber Technology Center and the Manufacturing Demonstration Facility, both at Oak Ridge. And then the Ash Beneficial Use Facility, kind of the first of its kind facility in the world, that's being managed by Southern Company down in Georgia. We have a very diverse, very large team. As I said before, the applicant here is IACME, the Composite Solutions Corporation. We're also working with, as a member of the team, the Geological Survey of Alabama, Oak Ridge, as I mentioned, Roane State Community College for the workforce development piece. Southern Company is playing a key role in the waste stream reuse that we're talking about in Task 3. The Tennessee Geological Survey is working with the Geological Survey in Alabama, along with the University of Alabama at Tuscaloosa on the resource assessment piece, which is Task 2. And then UT Knoxville will be leading on Task 4, the strategies for infrastructure, industries, and business. And then also playing a part in Task 5 of the technology assessment, which will be led primarily out of Oak Ridge. The Technology Innovation Center, as I mentioned, will be led by the team at IACME. And then the stakeholder outreach and education, which I'll talk more about in a second, is going to be kind of co-managed by IACME, led by IACME, but also with key inputs from Roane State Community College, and an important or innovative environmental justice piece of this that's coming out of UT Knoxville as well. And then I've highlighted some of the other program partners or project partners here, everybody from Alabama Power and TVA to state agencies, to coal companies, to RE recycling centers, a whole bunch of different groups, including more community colleges for the workforce development piece. So why is this important? Why is this project important to the region? Well, coal production in Southern Appalachian Basin has fallen a lot over the last decade, leading to lots of job losses. So we went from about over 21 million short tons in 2005 to around 9 in 2020. So a significant drop over the past decade. And that decline isn't expected to go away. So some work here at the Baker Center looking into coal plant retirements has indicated that many of the coal plants in the region are going to retire by 2030. And so we don't expect this to rebound, at least from in the Southern Appalachian Basin. And so what do we do? Well, sort of the emerging industry that has come out of this region, as I mentioned before, has been auto manufacturing. And so you see here a map of plants for companies ranging from Ford to GM to Nissan, Mazda, Toyota, Kia, BMW, really all over the automotive landscape that have decided to locate in this region. And several of them have recently announced or recently started initiatives, large initiatives, billion-dollar initiatives around electric vehicles. So the most recent one was the Ford plant that is being the $5.7 billion investment in electric vehicle and battery manufacturing right outside of Memphis in West Tennessee. But then there's also the Volkswagen plant down in Chattanooga. All of these are going to be kind of key pieces of this regional supply chain that we talked about. And so this region in particular is sort of focusing on kind of transitioning away from coal mining as the major economic source and potentially using the coal in the ground, not to burn, but to potentially help as an input and a key element in the supply chain for this new emerging industry that the region has seen kind of growing in recent years. Stakeholder outreach and education. So IACME will be leading these efforts using a variety of techniques that they've perfected over the years. We've identified 4 key groups that we're going to be trying to reach. The local communities obviously are going to be an important piece of this because they have really been bearing the brunt of the legacy impacts of some of the coal mining activities in the region, but also the burning of coal for electricity production. State and local governments are obviously going to become an important piece of this as well. But because we're really trying to focus on the supply chain pieces of this and really trying to focus on what are potentially economically viable opportunities in the region, the business partners and economic development groups, along with nonprofits, are also going to be key stakeholders as well. The educational program is going to leverage a workforce collaboration network that has been built at IACME with partners across the U.S. And using a number of innovative programs that they have developed over the years. I would say that there's really 2 challenges that we've highlighted that we think are unique. I mean, we sort of face a lot of the same challenges that some of the other basins are going to be looking at in terms of characterization and separations and things of that nature. But there's some interesting pieces of this because of our region, and I do like the earlier mention to kind of the regional approach to this. That's sort of taking that approach has really kind of helped us think about this. But one is fostering a supply chain that doesn't currently exist. So we have project partners at Southern Company who have already developed what we're calling kind of the upstream piece of the supply chain. So that's the use of the coal and the coal ash in a number of products, primarily construction grade products. But we've already got a market around the coal ash in the area that's being used, specifically certain types of coal ash. And so finding a way to make a link up to core CM is going to have to pay attention to those upstream links. But we also have a number of the downstream supply linkages. So we have, like I said, the automotive manufacturing in the region that's already using REs and CMs as inputs, but as a number of others have pointed out, we're typically importing these from outside the region and especially outside the United States in many cases. And so the traditional approaches that the academic folks would use to kind of characterize these supply chains are really tough for those midstream links. So how do we go from coal ash to the RE within the region? Because that whole entire industry doesn't exist. And so part of what we're going to be challenged to do is to come up with methods and techniques that we can use to talk about what would need to happen on the ground. What are the business community climates that would need to be on the ground, along with the technical expertise and technology innovations that would allow those supply chains to emerge, and which is a kind of a challenge and unique challenge that we'll be facing. The other that I think is really going to be important is going to be this environmental justice consideration. So considering the impacts of coal mining and coal waste streams on the underserved communities, it's kind of a catch-22, right? And in a lot of ways, there's an environmental justice component here to making sure that a lot of these coal wastes are being used in a way that may potentially benefit the community. That's sort of kind of the essence of environmental justice here, right? Is that they have been kind of dealing with a lot of the repercussions of these coal ash and coal mine tailings for years. And so a restorative aspect of environmental justice here would be to have these facilities located in places that have already bared the brunt of these things. On the other hand, many in these communities may want to move on to other things, right? They may not want to remain reliant on these technologies and these extractive industries. So we're going to be engaging in a two-step process to reach out to those communities to identify the impacts and to figure out what those assessments are through a two-step process, like I said, that will involve surveys and interviews with a number of people living in and around those communities. And we have some really cool ideas coming out of UT Knoxville here with some folks that have done some environmental justice work in the region in Alabama and Georgia already. So we're excited about that piece in particular. So with that, given that we're running short on time, I'll wrap up and look forward to any questions. Thanks.
Great. Thank you so much, Charles. Next up, we have Dr. Samuel Taylor from West Virginia University's Energy Institute.
Gang, let's see here. All right, hope that looks good to folks. So it's good to be talking with y'all. It's
Samuel, sorry to interrupt, but you switched the settings, I think the opposite of what we wanted.
better.
There we go. Perfect. Thank you.
Beautiful. Well, it's always tough to bat cleanup, especially in a crew like this, where I think you guys have heard the same talk, what, 11 times or 12 times in a row now. So I'll try not to repeat things that you've heard several times already today, and maybe put a little bit of the spin of our basin on it. Many of the things you've heard today in terms of the resource characterization, trying to identify, Dr. Sims nailed it. What do you do with supply chain? How do you do supply chain analysis if there is no supply chain to start with? These are common issues across the region. The other thing that is big for us, the environmental and social justice aspects, again, a common thread through these things in, yes, we want to figure out how to, make lemonade out of these lemons that we may have in some of these regions, but we have to be careful then that the new process that we arrive with, are there any, environmental effects or other effects in the community? And we need to make sure that the benefits that come out of these projects, somehow come back to the communities that we're engaged in. So jumping off the, kind of start, again, this is a bit of perspective. We folks have been talking the national perspective in a lot of the conversations today. And I wanted to bring it just a little bit more local. Why are we, at WVU, why are we in the region, has bought into this concept? Why are we already engaged in work with, Dr. Paul Zimkavich and some of our partners, University of Kentucky and Virginia Tech in this area? And, I picked West Virginia here. Coal production, it's been an anchor for things in West Virginia, an economic anchor for a very long time. But, the confluence of lower costs of production in other basins, changes in competitiveness between underground and surface mining, low natural gas prices, the Marcellus Basin in our region, switching to natural gas and renewables and power gen, and then COVID-19 in 2020 have all led to West Virginia coal production. So we've seen some tables today that talk about, the production in tonnage. To put that in perspective, West Virginia coal production in 2020 is at its lowest level since 1920. That's the lowest 5-year period I could find data for since 1918 to 1922. So, you know, for perspective, the last time production was this low over a 5-year window, it was actually being done with, you know, picks and mules. So as we're chasing some of these economic transitions, you know, and energy transitions, the activity in rare earths and critical minerals recovery, the ability to think about how we can get into the business that, you know, builds on strengths we have in the region and grow that going forward becomes, you know, hugely valuable in our region. So a bit of a background, you know, sort of the who, what, when, where, why here. So MapCore, the name for our project, which is, we say mid-Appalachian, the ARC's definitions for North and Central, we kind of cherry picked right in the center, looking at a region from Southwest Pennsylvania through West Virginia, Eastern Kentucky, Western Virginia, and Eastern Tennessee. We plan to look at upstream production. Again, that's maybe the part we understand the best. The midstream refining and processing, which actually is where we're finding a lot of gaps in the kickoff of the project. And in thinking about how you can get into downstream manufacturing of high value products, whether that's, you know, rare earth using products or high value carbon products. And again, you guys have heard this all afternoon, you know, we're going to identify the barriers in connecting these things, which are significant, the technical, workforce, and economic considerations of how we do that. And, you know, again, to kind of brush it lightly, you know, you start to address some of these social and economic justice things sort of through the progress of this project. The fact that we're looking at this, that we're trying to figure out how to bring, you know, resources and tax base and activity into some of these regions becomes important. And, you know, it was not a coincidence at all. The lower map on my slide here is county economic levels, distressed being sort of the worst in red there. And our target study region is intentionally sort of focused where you see most of the red and orange in that map there. At the top, this is a graphic from our friends Aaron Noble at Virginia Tech. You know, thinking about how this supply chain, you know, starts to build out. There are a lot of co-products and co-processes, a lot of co-feedstocks that you start to think about as this whole project and this whole ecosystem comes together. And that does make it actually tricky to analyze. We've got a great team and some great partners on that, but it does speak to it's maybe not as vertically integrated as, you know, some historic industries in our region have been. So our core team, that's the sort of the, as they say, in the SOFO partners, it's ourselves. We're in the lead on this one, but closely aligned with University of Kentucky, CAER, Virginia Tech. We have great partners at Oak Ridge. We're very excited to have them along in the carbon materials space. The geologic surveys in Kentucky, West Virginia, and Pennsylvania. Centerra helping with mining engineering and things in that space. And in Tech Connect, West Virginia is an incubator startup kind of facilitator that helps to get us out into these spaces around the region, how we can, you know, how can we connect some of these development projects, or how can we connect technology in, you know, out to their end users. So we've specifically talked about the Technology Innovation Center. I think it's going to be a virtual center where, you know, we work to connect. Again, heard about this all day today. You know, many of these places have regional incubators and innovation centers. And so, you know, thinking about this more as the connector, the hub between, you know, getting these things linked up versus a brick and mortar center is where I think we're going to go. But we're going to take a look at that over the next couple of years and flesh that out. It is a fairly large geographic region. And one of the things that keeps coming up in our conversations with our partners is that, you know, if they're trying to move things from lab to field, or if they're trying to move things out of lab to maybe slightly bigger lab, having facilities that are close to them and close to where the project is actually going to happen in the field becomes important. And that kind of highlights the virtual center approach. So the significance of the work, you know, I keep thinking about this in a near term and a long term kind of thinking. So near term things we're trying to do in this project, you know, the resource assessments, all the projects, resource assessments for feedstocks in the basin, trying to identify, you know, there are novel production technologies or things that may have a unique application in our area for production. We've heard it all day today, infrastructure gaps, infrastructure resources that exist in the basin. And then, what are the in-basin commercial partners that we can start to link up and understand, their sourcing requirements and limitations. And in long term, the strategic vision for this is thinking about the regional and national supply chains, how we can start to do, value-added technology development that maybe can go after some of these gaps in development and deployment, and ultimately, look to fill some of these supply chain gaps and, technology gaps to get things out of the labs and, out of the brains, the researchers in these projects, and, into commercial deployment and providing products for the United States. So the project structure, and sort of, everybody needs to talk to everybody in our project. So we're, how the basin assessment feeds, how you would produce it feeds, what the technology you might use to then upgrade those products, or how you might, go from a raw material into an upgraded material. And then the economic assessment for what does that really mean? Is that a project you would follow given, maybe some limited resources? And then how do we feed that back around? So I've highlighted just a few of the project principles here that are leading these tasks. And then, our industrial advisory committee is larger than what I could put on the slide here, but we're working to connect end users of some of these materials. So folks in defense and automotive space, we've been hearing that again all day today. Midstream manufacturers. I'm a former automotive guy, so thinking about, tier 2, tier 3 suppliers, how does that look? And then who are the raw material, suppliers, whether that's coal companies, landowners that may be sitting on coal waste products on, former mine lands or former mine sites. And we're working around the region pretty aggressively. And that's actually where most of our work so far in the project has started, is outreach with those partners and getting everybody up on the same page. So I've been through this, moving quick, 10 minutes here. So some of the key people. So Jim Wood is our project principal investigator. Jim had history with the Department of Energy in the coal office before he came to WVU. Jim was not available today, so I'm pinch hitting for him. And again, a great team of project principals and institutional leads from around the region, highlighted again by some fantastic people in Kentucky, Virginia Tech, the local geological surveys. A wrinkle that I think may be a little bit unique for us is we are taking a look at shales, black shales in the Marcellus and the Utica, and are there any opportunities for mineral recovery or enrichment in those? And we've got a nice piece of that tied in with the geologic surveys as well. So the outreach plan, again, we've heard this a bunch today, trying to get out to the energy companies, utilities, the folks that are maybe holding on to what we're now starting to think as resources. That's been a big conversation in the region lately is, before you couldn't pay people to take this stuff, it would be hard to maybe move some of these wastes. And all of a sudden, folks are trying to think about, is there value in that? And do they want to hold on to them? So trying to connect those dots and understand, maybe where the economics of these processes actually land is a big thing we're working on right now. We have partnerships with regional community and technical colleges, the state departments of education, state commerce departments, all kind of yoked up and pulling in the same direction. Again, I think that's a common thread on just about every project we've heard today. And then the idea with the Technology Innovation Center, as we get down the road and we start to understand how these things come together, I've shown a few highlighted organizations here that are dispersed geographically throughout our study region, but all have similar capabilities for doing, lab space, piloting, technology transfer, prototyping, these kinds of things. And, and thinking about how could you take some of these processes, do they spin off into standalone businesses? Do you think about licensing them to other folks? Do we just need bigger facilities in terms of scale up? So again, I think we've heard this a bunch today. So the reach through the region is pretty extensive. We are trying to go from, workforce development through mineral understanding, through technological development at some of the universities, and then think about how to feed that back into industries at the front end of these projects. So thinking more locally, project initiation, challenges and opportunities. I mean, the challenges and opportunities at the big scale we've heard a ton about today. Supply chain doesn't exist. How do we think about developing supply chain? Something else that's been, kind of eating at me When I say challenges are philosophical, it's, what is the long-term plan for deployment of these technologies in the basin? How are we going to address some of these economic justice kind of considerations to ensure that, in West Virginia, it's not another, take the resource and run kind of project, where the things, the capital flees the state and, maybe there's some jobs, but that's about it in the region. The need, kind of highlighted at the beginning is now. We can't make these projects move fast enough, even with the full court press that we're getting, with this larger effort in DOE. The other thing that's a little bit, and I'm concerned about personally is thinking about, say the opportunity is now, is that there is a ton of infrastructure funding we've been hearing about that may be available, but we don't necessarily know all the answers to these questions. So I worry a little bit about how can we link up the infrastructure piece, the larger capital funding piece, to technology that we don't completely understand or resource that we don't completely understand. But of course, we've heard all day today, the opportunities are potentially significant. Again, there have been tons of slides on this today, so I didn't double dip everyone on the market for lithium and cobalt and neodymium. We know it's big, or you wouldn't be on this phone call today. When I say project stand up is taking longer than I'd like, I think that's probably true for everyone. We got out of the gate at the end of the fiscal year, and just the usual grind of getting subcontracts stood up, non-disclosure agreements in place, and all these kinds of things to make folks comfortable is taking time, and candidly, some of that's being exacerbated a little bit with COVID and things like that. So no matter how fast we went, it wasn't going to be fast enough, but we're pushing hard and hope to be up and highly effective in the first quarter of 2022. All right, again, helped out by everybody else going before me today. That actually brings me to the end.
All right. Thank you so much, Sam. Really appreciate it. Thank you to all of our presenters and to everyone who joined us today. We are a little bit over time, so unfortunately, we're going to have to skip the Q&A session. However, if you have any questions, please feel free to send them to me or to any of our presenters, and we'll make sure to get back to you with answers to those. As a reminder, as I mentioned at the beginning, we will be having part 2 of this series next week on the 8th. So I will enter the registration link into the chat there for everyone to see. Again, thank you so much to everyone for participating today. This has been really informational, so much info that we couldn't answer questions, and that's okay. But I hope everyone has a good rest of the week and a good weekend, and happy holidays if we don't see you before then. Bye all.